Hi everyone, thank you for joining. We'll give another minute or so to let everybody join and we'll kick off the session. All right. So hello everyone and welcome. Thank you for joining us today. Today's session is about optimizing cost and performance for workload running on AWS and specifically through the storage layer using Amazon FS6 for NetApp ONTAP. The goal is to show you how you can strike the right balance, delivering the performance your application need without overpaying for resources you don't use. My name is Semyon Mazor. I'm a senior product specialist here at NetApp, focusing on Amazon FS6 for NetApp ONTAP. And today I'm joined by Ty Holstrom, the man in the hat. Hi, Ty. How are you? You're on mute, Ty. You're on mute. You need to unmute yourself, Ty.
Of course I do. Hey, it's good to see you, Simeon. It's good to be on another webinar with you. Love doing this. It's good to see everybody. My name is Ty. I'm a solutions architect, product solutions architect on the product side, and I cover our ISVs and game development for FSX for ONTAP, but also Workload Factory, which I'm excited to demo today. Good to be here.
It was a while since our last webinar together, so I'm glad having this one.
Yeah.
Um, just quick housekeeping. This session is live. It is also being recorded. It will be available on our YouTube channel probably by tomorrow. If you have any questions during the session, please send them through the Q&A panel. We will try to address as many as we can as time will allow us. And if you have anything that you would like to dive further, you are welcome to schedule one-on-one meeting. We'll send you the link through the chat. So you will get a one-on-one meeting with an expert free of charge. So you're welcome to do that as well. Now, before we dive in, we'd like to get a quick sense of your familiarity with Amazon FS6 for NetApp ONTAP. So please take a moment to answer the poll that you see on your screen. There's no right or wrong answer. It simply helps us calibrate the level of details as we go through the session. So the question is, have you heard about Amazon FS6 for NetApp ONTAP? Whether yes, I'm familiar with it, or I've heard of it but don't know much, or no, this is my first time I'm hearing about it. All situations are great because we will address all of them. Just could calibrate a bit more of what we're going to cover here. Yeah, usually there is a mix of people that that join the sessions, and we see more and more awareness of FS6 ONTAP. So it makes sense that more and more people join. So we see roughly 60% of the people today are familiar with it. 36% have heard about but don't know much, and just 5% hearing about it for the first time. So this is great. Thank you for answering the poll. And we will, in any case, we will. This is a great session because it will. I think this is exactly the great mix to have on this session. So first, we will have a very short intro to align on what is FS6 ONTAP and NetApp Workload Factory to make sure we're all on the same level in this regards. And then we'll have two parts. First, we're going to focus on the key capabilities that directly impacts cost and performance. And then we'll move to a live demo of NetApp Workload Factory, while Ty show us how those capabilities applies in real environments. So FS6 for ONTAP is an intelligent storage service for AWS workloads. It is an AWS native service provided, supported, and built by AWS, and it's built on NetApp's ONTAP data management technology. Now, what makes it unique from other cloud storage services is the breadth and depth of built-in capabilities, which we group into five main pillars. The first is accessibility, providing file, block, and object storage, and also with multi-protocol access, so data can be accessed no matter from where and which type of platform and by which protocol. Second pillar is for resilience and protection, providing high availability, efficient snapshot, which we'll touch upon today, efficient backup, and built-in cross-region replication technology for disaster recovery. Third pillar is for data security, with tenant isolation, Active Directory integration, immutability, malware protection, and built-in autonomous ransomware protection. The fourth pillar, which we are going to dive in more details today, is about cost performance. And the fifth pillar is for data mobility and copies, including technologies like thin cloning, migration, flexible data copies, etc. So as I said, we're going to focus today on the cost performance aspect, but just to give you a bit broader context and understanding that these benefits come as part of more comprehensive storage platform.
Yeah, real quick before we go off to the next slide, Simeon, just want to make a quick comment on how we see a lot of our customers benefiting. It's crazy. There's so many workloads, so many different solutions that you could leverage all of these features for. And I've seen it in odd edge cases like game build pipelines. One of our game customers builds their games on top of FSx for ONTAP, and they actually have to distribute that game once they build it. And historically, they would just dump that off to S3. But as an example, we've got S3 access points. And so now all they got to do is put an S3 access point in front of that volume with those files, and then they just distribute out immediately without doing that full-on ETL process from block and file to object. So it's really saved them time in their pipeline, saved them a lot of money in their pipeline, and it's also reduced a lot of their friction in their delivery process for the actual game build. That's just one of many, many examples. We're talking about hybrid scenarios where people are bursting the cloud for archiving data, protecting that data in different and unique ways that they weren't able to in the past with complete access to AWS at this point. So there's just a lot of really cool things, and it's a Swiss Army knife at the end of the day. There's not another file system that can do what we do comprehensively at the scale that a lot of our customers need. So it's really cool to see the stories play out with our customers.
Yeah, thank you for commenting on that. I think this is exactly the point here. This is the Swiss Army knife with all the different capabilities, because organizations, especially with large-scale enterprise workloads, operational workloads, doesn't need just one piece. They need protection and resilience and data security and mobility and, of course, cost optimization. So yeah, this is exactly where FSx ONTAP can make the difference. Now, the other tool we will include today is Workload Factory. And as I said, FSx ONTAP is a native AWS service. It's not a marketplace solution. So therefore, you can operate it directly through the AWS console with all the usual tools you use on AWS. In addition to that, and to make it easier to deploy and operate workloads correctly, NetApp also provides Workload Factory. It is a free-of-charge SaaS framework that helps in planning, deployment, and ongoing operations following the AWS well-architected best practices. So this is a tool that will help you to implement all the right configuration, to make the right optimization, and align with the well-architected best practices. It significantly shortens deployment time, reduces manual errors, and most importantly, supports continuous optimization over time through observability, automation, and recommendations. So shortly, you'll see how it ties directly to FSx for ONTAP. So now that we all align on what FSx for ONTAP is and what is Workload Factory, let's focus on how FSx ONTAP specifically helps to improve cost efficiency and application performance. So those are 4 real examples of customers from different industries that represent how FSx for ONTAP delivers in practice. So ARM could now complete EDA jobs 50 times faster by taking advantage of intelligent caching. Orion achieved 65% reduction in storage cost, again, 65% reduction in storage cost, while also improving latency to under 5 milliseconds. So this is strong illustration on how FSx ONTAP allows customer to reduce cost and in the same time improve performance. Rivian saw 50% faster time load times, and about 2 million savings annually, mainly thanks to thin clones. And this means that the engineers at Rivian can now load files twice faster and develop faster electric cars. Atlassian saved $2.1 million by leveraging built-in storage efficiency. So as you can see, those companies and many others optimize both cost and performance at the same time. And also, as you can see from those examples, the impact is not limited to the scope of IT. It impacts the entire workload and the business of the company. So it's not just it's much beyond the selection of which service I use, storage service I use. There is a much broader impact by that selection.
Yeah, and Atlassian was a really fun case because I had the pleasure of being on that actual migration for them. And that 2.1 million savings, that was roughly around 45 to 50% of what they were actually spending. They were roughly around 4 million. So in migrating from an on-prem system to AWS on FSx for ONTAP, that migration was really seamless and easy, but they were able to actually reduce a ton of cost and spend in their storage that supports their actual Bitbucket cloud. So it's like I got to be a part of the developer of the developers actually saving all of this money and driving efficiency in their development process. And it's cool to see it right next to Rivian because that's another developer using thin clones in their development process, which is a similar thing that I see often in game development and other ISVs building in AWS. So it's again been super cool to be a part of their stories in optimizing cost and efficiencies into their actual development pipelines.
Yeah, and I think again, number just speaks for themselves. It's not just optimization of, I don't know, 10 or 50%, which by itself could be substantial, but we see such numbers, I think they speak for themselves.
Yeah, it's big.
So let's see, look, there's a question how they achieve that this impact, right? So there's three major aspects that allowed it. First, data footprint reduction technology. They reduced the physical storage footprint through built-in storage efficiency, efficient snapshot, and thin clones. Together, those capabilities allow to store the same data using less capacity while maintaining performance. The second is intelligent steering. Keeps active data on high-performance SSDs while automatically moving inactive data to lower cost capacity storage. And the third is elastic performance scaling that lets to adjust I/O throughput and SSD capacity up or down without redesigning the environment, and more importantly, independent of the selection of used or provision capacity of the storage. So FSx for ONTAP provides a complete and unique set of enterprise-grade features that continuously optimize both cost and performance. Now, I would like to unpack a bit more on what FSx for ONTAP offers in each of these areas. We won't go too much into technical details today. We'll share additional resources if you would like to explore further. But I do want to explain how FSx for ONTAP optimizes cost and performance, so we have more information about that, and then Ty will showcase how we can see that and visualize that for us. So let's start with the storage efficiencies part, because this is one of the fastest way customers see meaningful cost reduction. In many cases, we see around 75% of storage cost reduction, and again, without any compromisation on performance. So FSx for ONTAP applies three core techniques in this context. Deduplication, it identifies duplicated data blocks and stores them only once. And this is especially powerful in environments with repeated content, like many copies of the same files or templates. The second is compression, which reduces the size of the data, so it consumes less capacity, kind of zipping it. And the third is compaction, which combines partly filled blocks to eliminate wasted space and improve how data is laid out. So again, there's more details to understand it in depth. We're trying to kind of give you a brief coverage of what it provides. These efficiencies are not one-time optimization. They're built into the platform and designed to work while maintaining the high throughput. The end result is that the same logical dataset consumes less capacity storage, which directly lowers the monthly storage bill.
Yeah, so I wanted to jump in here real quick because I was thinking about a customer that I recently worked with. I was trying to imagine, oh yeah, which customers benefiting from dedupe compression compaction. In many cases, most customers have efficiencies on, but I thought this use case was really cool. It just popped into my head. I had a customer that they were actually deploying VDI workstations in the cloud, and they were trying to optimize the actual user data and application data that was actually being deployed and mounted to each one of those VDIs. And this was for a couple thousand VDI systems that are being used by developers. And they said, hey, how could we do this in FSx for ONTAP? Because what they were doing was mounting LUNs to these VDI workstations. Turns out that you can add multiple LUNs in a single flex vol or volume on FSx for ONTAP. It'll dedupe across all of those LUNs because this data is similar. They were seeing roughly around 72% of that data being deduplicated and compressed and compacted. So they were able to justify the use of FSx for ONTAP for this particular workload just on that very basis alone. And that didn't even include all the other bells and whistles they got with the file system itself that they're now using for other workloads right next to that workload on the same file system. So just really cool to see that amount of savings for a bunch of block LUNs. Pretty interesting.
Yeah, it's nice that you bring that example. When I work on this slide as preparation, was thinking about presenting it together with you. I thought about the same example as well. All right, so let's move forward. Next capability here is theme provisioning, which lets you to allocate storage based on what application might need while paying only for what they actually use. You can provision volumes at their full logical size without allocating SSD capacity upfront. SSD storage is consumed only when data is written, allowing you to safely overcommit capacity, start small, and avoid paying for unused headroom. This is especially valuable because application teams often request more space than they ultimately use. So the theme provisioning prevents those just-in-case allocation from turning into real spend. And SSD capacity approaches its limit, you can expand seamlessly and automatically to accommodate future growth. So this is another aspect. Next is NetApp Snapshot. And the key point that they are designed to be highly efficient. Snapshots are created instantly because the system does not copy the actual data blocks. Now, when I joined NetApp, it sounds like kind of magic until you understand how those pointers actually works and that they're not involved in any actual data movement. So this is really cool and one of the bread and the butter of ONTAP and how it operates. So what it offers, it captures point-in-time view with minimal overhead. And that also what makes those snapshots non-disruptive. So they have neglectable performance impact, they are very cost efficient, and because they consume very little additional storage, they have a minimal impact on the capacity and therefore for the cost. And this happens because only the changes made after the snapshot are actually written. So practically, this enables two outcomes. First, you can snapshot frequently without worrying on your doubling storage cost. And second, you get faster recovery option if something goes wrong, whether it's accidental deletion, corruption, or an application issue. And as I said, this capability serves as a ground for additional functionalities. One of them is theme cloning. So theme clone is based on snapshots, so you get a new writable environment without actually copying the underlying data blocks. It is a lightweight, point-in-time, fully functional copy of the data available in another volume. Unlike snapshots, which are in the same volume, you get it in a different volume to be accessible through different environment or different application. So this is why it's created instantly, it's non-disruptive, and it has minimal storage overhead. Importantly, it behaves like just a real volume, so application can use it normally for reads and writes. And this is extremely valuable for dev test environments, for analytics, for QA, and practically any scenario where multiple teams or pipeline need parallel environments. So instead of paying for multiple full copies of the same dataset, you create clones quickly and only it consumes incremental capacity as changes are made. So this kind of wrapping up the first area of data footprint reduction. And now I would like to move to the other aspects, which is the tiering.
Hey, real quick, Simeon, sorry to interrupt, before we do, um, I think this is just my hot take for the day, but the thin cloning capabilities we have is after having it for so many years, is still an underrated feature. And I think it's because, like a lot of customers, when they originally saw the feature, it was purpose built and on prem. And when you're on prem, chips and disks, they're cheap. And so you don't really think about, hey, I need a feature to be cheaper on disk because I can just buy a cheap disk and add it. But now, when we're talking about solid state storage in the cloud, it's a whole different ballgame. If you have to duplicate that data in some way, let's say you're in a pipeline that is developing some type of software that has a lot of large artifacts. See this a lot in media and entertainment and gaming. In their actual development pipeline, when they do their builds, in many cases they have to duplicate what that build is, which is usually some type of block volume. And if you're actually making that copy, you're wasting time waiting, and it costs essentially 100% of that original volume. But because we have thin cloning on FSx for ONTAP, I'm not doing a copy, I'm doing a thin clone. That clone takes up zero space in the cloud. And it can actually be writable as well, which is really flexible in that type of pipeline. And so now, not only is my pipeline insanely faster because I'm not waiting, it's nearly instantaneous when it comes online and gets mounted, but I'm not paying for a full copy. I'm only paying for that initial copy. That's really useful if you're using block, for instance, in development pipelines with a lot of assets that are associated with those builds. Just one example of so many. Dev test scenarios for databases. We see a lot of customers using that. You saw it in some of the previous examples. So incredibly fun and useful feature of FSx for ONTAP that should not go overlooked. Thank you.
I totally agree. There's so many examples of customer, like you explain thin clones and they're saying, all right, nice, nice. And then they actually use it and say, why you haven't said from the first place that there's
Yeah,
such
exactly.
feature? So
100%.
yeah.
Yep.
We'll keep the question for the end, but I do see one that I would like to address. There's a question if NetApp Snapshot has a full backup on their own. So snapshot, just real quick, and we will keep the rest of the question in the end. Snapshots are stored on the same volume locally, so their first layer of data protection against, as we said, like a accidental deletion or something that you can restore very quickly from the same file system. And then those snapshots can be efficiently replicated to another file system or to a capacity pool and be served as a full backup solution. And there's several tools that you can do it with, including all the AWS native services part of that. So now let's move to the next part for data tiering. This is about paying the right price for the right level of performance. FSx ONTAP has two storage tiers. The primary storage tier is high performance SSD for frequently accessed data, which we call hot data, and capacity pool, which is a scalable lower cost storage designed for infrequently accessed data, which also called cold data. Now, when a volume is new, all data starts as hot. But over time, as access pattern change, blocks that become cold automatically tear down to the capacity pool. And if that becomes active again, it can move back. The movement is automatic and designed to align storage cost with the actual usage. And the practical impact is significant. You maintain SSD performance for the working set while avoiding SSD pricing for inactive data. So this is one of the most direct ways customers reduce ongoing storage costs without sacrificing application experience. Moving to the third pillar, and so far we covered multiple ways to reduce cost. Now let's look at the other side of the equation, predictable configurable performance. FSx ONTAP is designed to deliver fast and consistent performance with performance parameters that are configurable independently of the use capacity. So you can send guaranteed IOPS, which are up to 2.54 million, network throughput of up to 72 gigabytes, and SSD storage of up to 1 petabyte. And on top of that, frequently accessed data can benefit from additional acceleration through in-memory cache and NVMe cache to further boosting performance. So this is again, FSx ONTAP provide these high performance capabilities, and they are independent of the selection of the use capacity. So you don't need to take decision on then one. You can just change it according to the needs of your application and your workloads. There's two additional capabilities to be aware of in this context. First, you can increase or decrease the SSD performance tier of FSx ONTAP. This allows you to right-size your deployment as requirements changing, avoiding situation where you have either insufficient SSD capacity, which reduces performance, or over-provisioned SSD capacity, which drives unnecessary costs. And the second capability is the option to rebalance data across nodes. We haven't covered how FSx ONTAP is built or its internal architecture, so we haven't gone into concepts like volume, SVMs, nodes, and other ONTAP terms. But to put it simply, FSx ONTAP automatically distribute data evenly across storage system, so no single component becomes overloaded, and it does so without downtime or without requiring any application changes. This supports growth and changing access pattern by scaling performance accordingly and preventing individual node from becoming overly full and creating bottlenecks. So with this rebalancing capability, FSx ONTAP continuously adapt over time to keep cost and performance aligned even as conditions change. So to summarize, all these technologies allow you to optimize both cost and performance through three key areas. First is data footprint reduction with technologies that reduce your physical storage footprint through built-in deduplication, compression, and compaction, also known as storage efficiencies, as well as thin provisioning, lightweight snapshot, and thin clones. Second, with intelligent tiering, this is another major level. And there's a single feature that can have significant impact by aligning cost with data access patterns. And third, elastic performance scaling lets you adapt IOPS and throughput independent of capacity, grow or shrink the SSD tiers as needed, and distribute data evenly across the file system. So altogether, this complete and unique set of enterprise-grade features provides unparalleled optimization of both cost and performance. It is also worth noting that FSx ONTAP can enable additional cost savings beyond storage. So for example, through improved compute utilization or reduced licensing costs, such as in databases workloads. So together there's more than what we discussed today, but we're focusing today purely on the storage aspects and what it provides in the context of cost and performance. Now, this generally concludes this section, and we'll move to the next part where we showcase these capabilities in action. But just before we jump into the demo, we'd like to understand your biggest cloud storage challenge today, so we can tailor the demo to what matters most for you. So there will be now another poll on your screen, and the question is, what is your biggest challenge with cloud storage today? Whether it's cost optimization, performance consistency, capacity planning, visibility and control, or something else. Now, Tai, would you like to guess what would be the main challenge?
All these are so important, and the other button at the very bottom is full of so many other important challenges, I think. But I will tell you, 9 times out of 10, every discussion I have, even if it's focused on a performance challenge, it ends up becoming a cost discussion. Cost is important, and if you just straight go into the cloud cold turkey, it can be very expensive not having an understanding of how to use the cloud. But that's why we're here, is to help you optimize that cost. But we end up getting into that discussion a lot. Yeah, there we go. Look at that.
Yeah, and yeah, you're right. 62% says cost optimization is the main challenge. Then we have 15% for visibility and control, and then we have rest for performance consistency, capacity planning, or others. So
Yeah.
thank you for answering that poll. And I think now we can move to the next part for the demo. So Tai, the floor is yours.
Yeah, sounds good. Also, I saw a couple of questions come up in Q&A. First one was is capacity pool S3 Glacier storage. It's not, it's just regular S3 on the back end. We have a lot of conversations going on about what the future of that looks like, but for now, not Glacier. And then another question was, can you force migrated data to the lower storage tier back to the SSD performance tier? Answer is yes. Depending on the actual policy that you set. So if you do an auto policy, basically if a block is not touched, ONTAP moves it down to capacity. Yeah, no problem. Once it gets touched, after it has been moved, it will move it back automatically for you. There are other ways within the CLI to make things happen manually, but automatic is usually the recommended approach if you're going to use it. So hopefully that answers your question as well. And without further ado, let me jump over to my screen here and let's get started on the demo. Now you heard a lot about FSX for ONTAP. You'll hear a little more, and hopefully you see my workload factory screen here. Zoom used to not auto switch to your screen. It would show the video. Now it's not, so that's kind of cool. But big questions here. We're talking about cost optimization, expenses. How do we optimize and become efficient, etc. I think what would be really good to talk about is the context of cost within how you're actually managing file systems, specifically FSX for ONTAP in our case. And we have Workload Factory that my team has been developing for a year and a half, 2 years now, which has been really cool. But basically, this is a free-to-use tool. It's a completely free service from NetApp. There's nothing to install. There's not an agent to necessarily install to use Workload Factory, no servers or anything. You connect it to your AWS account, and essentially within minutes, you're looking at your entire FSX for ONTAP estate, whether that's in one AWS account or multiple AWS accounts, one region, multiple regions, multiple file systems. We combine it all in one kind of single space for you to better and more effectively manage that environment. Now, speaking of cost, I'm going to go into our storage view here within Workload Factory. And as it's loading, if you look on the left here, you're going to see a button that says cost. We've recently introduced this to Workload Factory because we've been having a lot of conversations around cost and the exploration of that cost. I think I've just sat here on the screen too long, so I got to reload the actual demo, of course. Good old Murphy. Strikes again. UI unable to render. Okay. I literally was just using this. Let me close and reopen. There we go. I recently had a VPN upgrade, so I've
This
had
is
all sorts of weird routing issues.
this is all
Now,
because you are not using a video.
I mean, what in the world? Uh, wow, something's really odd with my routing.
I'll try to log in the meantime.
Yeah, let me know. I'm gonna try a different browser here. Sorry, everybody.
All right. Yeah, it logs in for me.
I think it might be this guy here. So let me reset.
You can show meanwhile all the two-factor authentication things, etc.
Yeah,
And we said that, yeah, it's all well
there we
architected.
go. There we
And here
go.
it goes.
I might be having a browser issue. Let's see. Let me zoom this out. There we go. Okay, back to what I was saying. Let's go back to cost here. Cool. Okay, so when I was trying to really formulate how we could really talk about cost optimization, the first thing I was thinking about was one of the big questions is what are we spending? What are we spending? Where's all that money going? What account is it going into? What file system is it going into? What region? And so I figured we'd start with our cost explorer. And what I can actually do is you see what I just did was I selected my account that I actually wanted to target in particular. You could select all accounts and it would pull up essentially all costs on FSX for ONTAP. I also have all regions selected, but let's go ahead and do just US East 1. I'll accept that. It'll auto adjust based on that filter. And it looks like I'm spending about, on average, $1,000 per month in this particular account, and about 25 cents per gig per month in this account. You can also filter on time, like date range, for instance, and on tags if you set tags for your resources. Highly recommend that. It's very helpful, helps eliminate any additional chaos as you're managing. You probably already know that too. But if I look down here, I can see the background. What's going to capacity pool as an example? What's going to my solid state tier? And on this particular file system, single AZ Gen 1, I got a total of about 3,520 gigs per month of usage. Total of about $1,800. So it's really useful in just at least first guiding your mind to think, okay, I need to look in these areas to optimize cost. You can also go in here and generate a report. So I've got some examples here that I've pre-created. In this case, let's say we've got this actual file system called AI cluster. I'm going to select it, and then what it will do is break it down for that particular cluster, and then I can actually download this report as a PDF, and I could actually send that out to maybe somebody who is trying to analyze cost and optimize our cost utilization in the cloud. But the whole point is this pulls everything together for every file system across your estate, breaks your spend down by storage medium. You can see what you're paying for, and then you can actually export this out. And for anyone who needs to justify cost to somebody at their organization, they have that report that they could just kind of hand over. Here's my receipt, So it's a very useful tool. Now, we've got an idea of cost, okay? The big question next is, what am I doing to get value out of what I saw? You may or may not have been seeing value in just that report alone, but then I want to kind of double click on some of those optimization areas. Where do I go to do that? To me, your next step would be taking a look at, let's just say I've got this account selected, 144, and I've got my region selected already. And I actually see all the file systems in there that were being analyzed. Now what I can do is click this download button here. It'll download a report for me. And if I'm lucky, actually, let me show all downloads, and I'm going to try to open it with Excel, because I think my default is Sheets, which I don't like right now. Yeah, no, or I'm sorry, Numbers. Let me go to Excel, and let's pull back up here. This report will then be completely accessible to you. And what it is actually looking at is utilization on file systems based on my filter. So in this case, you see the file systems that I had listed, and I can actually see SSD storage size. That was what was provisioned for the file system, what is used, and its utilization characteristics here. And as you can see, like TH demo of 4 right now is at about 95% utilization. Uh-oh, that's a concern. And at 95% utilization, I only have about 197 gigabytes actually being pushed down to the capacity pool. Okay, so that might be an area I want to take a look. Additionally, I can look at throughput, I/O, and CPU utilization as well. So we were talking about basically being able to optimize performance on our file systems and achieve high performance. This is a way that you would go to look at optimizing that particular performance. Our file systems, when you deploy them, really are deployed with three primary characteristics. That's the capacity, as you see in SSD, the throughput, and then the I/O. CPU utilization is essentially the CPUs that are dedicated to the file systems. Each SKU has its own CPU, so you can't really adjust the CPU itself unless you're adjusting the throughput, which is essentially your quote-unquote total compute size. The I/O, being related to disk, can be adjusted independently, naturally. So right now, all mine are at automatic, but you could manually change the IOPS that are available to that file system in completion. All right, so now I've got a more technical or granular view of utilization on the file systems. I'd like to take you to one other area. Sure, I'll save it, no big deal. To take a look at our utilization and maybe optimizing cost in particular on a file system. So what I will do is go to this particular file system, THDemo02. We'll take a look at what we call the well-architected status. What is this? There's a lot of dials and statuses and percentages on the screen. We set out to help our customers originally with Workload Factory, optimizing based on workload. But we quickly realized that our file systems, because they're Swiss Army knives, get used for multitudes of workloads. And so sometimes you just need to take a look at the file system itself. Are we configured in the most optimal way possible? And to think about that and rationalize it should be through the lens of the well-architected perspective that AWS carries. That's well-architected best practices for storage in their minds, in addition to NetApp's best practices or equivalent to well-architected. Because we're an AWS service, we like the well-architected framework. So we stuck with that. And in essence, what this report does is it will analyze your file system estate based on file system in particular, and it will take a look at a number of best practices that should be applied to the file system. It will run this scan daily. It will output kind of a total scoring based on the different views that we take on best practices. And then it will detail each one of those individual best practices out below, as you can see. And they are divided by reliability, operational excellence, performance optimization, cost optimization, security. Cost optimization, in this case on this file system, it's 100% cost optimized. But we can at least look at some of these that exist right now. For instance, like deleting unnecessary backups. There might be some orphaned backups sitting out there. Maybe you deleted a file system, backups remained sitting out there that you don't need. We're looking at that, and that's additional cost to you. Workload Factory will find that and tell you, hey, you probably don't need those. And you can either act on it manually yourself outside of Workload Factory, or you could actually use Workload Factory to view and fix that particular problem. Additionally, let's look at one that is not optimized. This in particular falls under operational excellence. However, we did talk about capacity management for FSx for ONTAP in particular. So Workload Factory is looking at this file system and saying, hey, you've got capacity on this file system, but it's a hard set configuration. You can't expand past it. You can actually use Workload Factory to take a look at that file system regularly and regularly monitor that file system. And if it grows at a particular threshold, 80%, 85%, let's say, I can then grow that file system by 15% increments. In addition, I could actually ensure that the inode count increases as well as capacity. Sometimes that's useful, sometimes it's not, but it's a capability that's there that's really cool. So in essence, the whole file system and inode count will expand as it needs to automatically, as either volumes are being added or growing based on utilization, which you saw in that previous Excel spreadsheet. So there's a lot of really cool stuff you can do here. We're looking at cost optimization, tiering cold data as an example. If that's not enabled, this will pop up as not being optimized, and it'll show you the number of resources that are not optimized. If I click view and fix here, and I think we'll run across this here in a little bit, it'll show you all the resources that could be tiered. Then you would click view and fix and it would tier them. So really cool area and space to think about optimizing cost in Workload Factory. Now,
And just jump in real quick. I think there's two aspects that we saw so far. One is to like the cost report, and the second is the well-architected dashboard, which two ways and kind of the added value of Workload Factory to have a summarized view and a aggregated view, but then with the options to drill down for details and also kind of implement the best practices automatically. I saw there's also questions related to how it's being calculated. We'll address the questions in a couple of minutes. We'll dedicate time to the questions, but keep them coming. We also send the link to schedule a meeting if you would like to try that or try Workload Factory for yourself. We already said that it's free of charge. You can just try it yourself as well. I think I covered different capabilities, so can you show us a bit more of that part, like different capabilities of FSx ONTAP and how you can manage those through Workload Factory?
Absolutely. So let's say you've looked at these three different angles. You now have kind of an idea of where you would like to optimize. And you did identify some areas of optimization in capacity utilization on these file systems. I could go to the very top level here based on my filtering, and I could, at the dashboard level, I see all the file systems and analyze the file systems and get a heads-up display of all of the information that is pertinent to those file systems. But being that we're talking about capacity utilization, I could actually go here at the dashboard level, and I can see that we're already getting some recommendations on some of these file systems. This one in particular, there's a potential area for savings. I'm only 48% utilized. I might know that this file system is maybe over provisioned. We're probably not going to grow to 10 TB bytes ever. Maybe we've achieved a certain stasis on that file system. So I could say, okay, let's select this file system. It's at 10 TB bytes. I'm going to hit continue. And I'm going to say, I actually am only using roughly 2 TB bytes. I'm going to change this to, maybe I want it right size down to, let's say 7 TB bytes. I can hit apply here. And what it will actually do is run a reduction or a shrink of that file system. Like we mentioned, Gen 2s, we have different flavors of FSx for ONTAP. We have the capability of right-sizing file systems. That's not just right-sizing upward, but also downward or shrinking the file system. Now, that's only a capability in our Gen 2 file systems right now, but you actually can, on Gen 2 file systems, shrink your total capacity on that file system, which is really rad. We're excited about that big feature. It's been a long time coming. So that's one way. Additionally, let me go back to that screen. Let's look at this one. It says it's 75% utilized. It's not making a recommendation in particular. If it becomes an emergency status, meaning it's seeing actual growth on the back end, it's opportunistically analyzing that. It might tell me, hey, you probably want to grow this. But maybe it doesn't know that, but I'm anticipating a big project that needs to land here. I could pick this file system and I can say, let's go ahead and grow this to 3 TB bytes, and it'll actually go and grow that file system for you, which is really great. So more headroom, systems keep running, or I'm over provision and I can reduce it and save some money on our provisioned SSD capacity, because that's how you're getting charged on FSx for ONTAP, along with any utilization in the capacity tier. All right, so let's go to the next step. We talked about storage efficiencies in particular. I'd like to go to a file system. And when I say storage efficiencies, I'm talking about dedupe, compression, compaction. Remember that customer that deduped those LUNs that I talked about. I'm going to actually click on this particular file system, and I can view the volumes that are on that file system. First and foremost, you can see I see all volumes here on the file system. I get a capacity distribution layout. If I hover over that, I can actually see I've got 800 gigs, written data size is 637 gigabytes, used solid state is 32, used capacity pool is 733. So I can actually see the distribution of where the data sits in that one particular volume there. I can actually go here and go to advanced actions and set the storage efficiency for this volume. And I think this one is not on. Area of optimization. So I click that and immediately I turn on dedupe, compression, and compaction. That's also selectable when you create a volume as well. You can say that should be on or off when you create the volume. But that's one area where you would actually establish that that should or shouldn't be on. And again, just to be clear, this is unique to us. You can't really see this type of distribution anywhere else. So that's where Workload Factory becomes really powerful add-on, again, free of charge, doesn't cost you to use it, to be able to see what's going on that file system and in those volumes. Next, tiering policy. If you look to the right here, you see a column, which is kind of hidden, but this is the tiering policy column. Let me just make sure that that's a little bit more clear. I'm going to hide a volume. Let's turn off ARP status, hosting SVM. I'm going to apply that. Now you can see the tiering policy a little better. Right now, everything is set to auto here on this file system. Not necessarily a bad thing. That's usually a pretty good state to be. Auto is generally the recommended tiering policy at the start. But let's say I want to change that tiering policy. It's auto. Maybe I want everything to be tiered on that volume because we're done with that volume. We don't need any of that data sitting on SSD, and I want to make that more efficient. I can actually select cost optimize. It'll push everything down to the capacity tier. Or maybe I've got a more a performance need. Maybe it's a database need that tiering that data could actually hurt the database because you don't want it to actually have to go crawl and pull back blocks from the capacity tier to the SSD tier. I could set performance optimization and it will actually only snapshot tier, which is great. It'll just push snapshots only down to the capacity tier, or I could just straight turn it off if I so choose. This is actually where I would manage the tiering policy for that particular volume. Let's say you don't see it enabled. Well-architected review will pick that up as well for you on top of that. So really powerful. You saw a couple of other options. For instance, if I go to basic options for that volume, I can set volume auto grow. We talked about auto growing the file system. I didn't talk about auto growing volumes. So at the volume level, you can actually set auto growth as well as thin provisioning. And if you do that, now you've got kind of a full complementary auto growth and auto capacity management across all the different levels of the file system, whether that's volume or whether that's the full amount of capacity allotted to those volumes. So there's a lot of power in Workload Factory just right here in this view. The last thing I did want to mention, we're coming up, I think roughly on my last kind of thing I'd like to talk about that Simeon talked about is snapshots. So if I take a look at one of these volumes, right now I can see all these volumes are protected. Heads up immediately, all protected volumes. Okay, let me go just confirm that. Let's take a look at our data protection actions, and I'll go to managing the snapshots for that particular file system. And as I dove into here, I actually don't see any snapshots created. That's interesting. First, why is that? Let me click Manage Snapshot Policy. If I click this, which I will come back to here in a second, it'll go to another screen, and I can actually create and manage actual policies that I would use on this file system per storage virtual machine, which is just a container for volumes on a file system. You can create a single storage virtual machine that has its own set of volumes, and you got multi-tenancy. That's really all an SVM is. You can set policies per SVM. So that'll take us there. We'll get there in a second. But let me go ahead and just show you what it looks like to create a point in time snapshot. So I got this one right here. I'm going to give it a label of daily, and maybe I just want to retain this particular snapshot for 15 days because I want to be efficient. I'll hit create. It'll go and actually immediately create a snapshot for that particular volume that I can then use elsewhere. And I can come in here and I can either edit it, I can access that snapshot, I can do a restore process off of that snapshot, which is really cool. And you may have seen this other selector here make this snapshot immutable. It is possible to actually lock this snapshot so that it cannot be deleted. And I would be cautious with this setting because if it can't be deleted, it's pretty rare that you'll be able to delete it yourself, right? It's immutable. That's the point. So that ransomware or hackers can't actually get into that particular snapshot. That might be useful in highly regulated industries, for instance. Just something to be aware of. If you see it, I wouldn't toggle it on unless you're really familiar with it. So reach out to an SME to talk more about it if you need to. Now let's go to this snapshot policy management real quick, just so you can see it. Again, this is for SVMs. I could actually adjust snapshot policies here. I could assign them directly to a volume from this view if you know what volume you want it on. I could edit that particular policy. I could create a new policy. This makes it a lot easier to manage snapshot policies, which in many cases you're doing in the CLI of FSx for ONTAP. And everything I just showed you requires no CLI, no code. So we try to make it as lightweight as possible to use, because once you start getting advanced with FSx for ONTAP, you'll find that the console in AWS is great for really rapid fire things. But once you need to do more advanced things like adjusting snapshot policies and getting down to the nitty gritty per volume, or creating snap mirrors, for instance, you need the CLI. What we did was we took a lot of those commands and we automated them with Workload Factory to make it a lot easier for you. All right, cool. So in about 20 minutes, I've gone from showing you and exploring a cost breakdown to actually what you do within Workload Factory to render your file systems far more optimal for a cost perspective, but also for performance. And I didn't even get into all the other aspects of Workload Factory and FSxN around protecting the data and what does that look like. So I'm sure you have tons of questions. I'd like to get to those as we have a couple more minutes left. So I'm going to hand it over to Simeon.
Well, thank you, Tai. Just one note, I think there's a couple of questions about Workload Factory. So I think that the point to emphasize is that it is an AWS native service. So you can use AWS Console to manage that. You can also manage the FSx ONTAP with ONTAP CLI. So for those who regularly do that from on-premises, you can do anything on FSx ONTAP through CLI. It is fully operational ONTAP version on AWS. However, there's a third option for people who are new to ONTAP, maybe not expert in storage, and want to get all the breadth and depth of the features that we covered as well as others. And I saw somebody relates to that case in particular. This is where Workload Factory, I think, is the classic case to have an easy way to operate all those features with a graphic interface. Starting from planning and getting costs and comparing costs to other storage services, etc. And also to actually deploying and then operating and optimizing it. So there's parts related to cost, parts as Tai shows to actual operational, to optimize the deployment in terms of the security, and to implement practically everything we covered so far. So this is just a couple of questions to address particularly to that before we go to additional questions. And to summarize or to wrap up our session today before we address the other questions, we have all the resources. I sent also the link to our YouTube channel. We'll send through the chat the links to other resources. You can dive further and to learn about these features and how they optimize FSx ONTAP. You are also very, very welcome to try Workload Factory yourself, to try to play with it. And if you wish to have a call with an expert that will guide you and help you both for Workload Factory, but also can address your challenges or concerns related to your workload and storage aspects, and see if FSx ONTAP can help you operate that, and see how you can optimize your environment on AWS. So we're getting to the end of the time, but I think we can stay a couple of more minutes to address questions that we see are coming there. I saw a question, Ty, like if you would like to address what is being used to determine the costs, and does the cost per gigabyte take storage efficiency in account?
Yeah, it's a good question. I don't know specifically the back end of Cost Explorer itself. It's using a number of AWS services. It has access to basically all the critical services that it can view cost on, but it is taking a look at utilization in particular. So the next question: does cost per gig take storage efficiencies into account? Yeah, because it's looking at the data that is sitting on the actual SSD tier, capacity tier, as it stands, and what you've actually provisioned against that. So there's all sorts of calculations on the back end. If you have a particular person you're working with at NetApp, like on my team, for instance, ask that question. We'll try to go find it for you in terms of what's actually happening on the back end. NetApp ONTAP licensing. Yeah, that's a good question. So we're talking about FSx for ONTAP, which is very different than ONTAP itself. Maybe Cloud Volumes ONTAP as an example, or physical on-prem ONTAP systems. Being that FSx for ONTAP is a native service, and it is AWS's product, AWS's service. It's technically not ours. It is actually immediately available in the console, which means it's more of a subscription service, just like all the other storage services that are available there, like EBS or EFS or S3. You pay per month and per use. Now, per use, what does that mean? That's probably where this matters the most, this question. You are paying for those three variables that I mentioned in terms of how you size a file system. So you're paying for the capacity that you're using. And when I say capacity that you're using, is capacity that you have provisioned for the solid state performance tier. So at a minimum, it's roughly around 100 terabyte per file system, or excuse me, 1,000 gigabytes or 1 terabyte per file system. That's the minimum. So you're paying for that at the start. You're also paying for the IOPS that you have provisioned and the throughput model that you have provisioned. Those three combined make up your monthly cost, essentially, in addition to the use of the capacity pool as well. So hopefully that clarifies that to some extent. But there's not really a licensing cost for FSx for ONTAP. There might be licensing costs for Cloud Volumes for ONTAP or on-prem ONTAP, but for FSx for ONTAP, there's not really a licensing cost per se. And everything, a lot of the features we talked about, those are all included in what you pay AWS.
See, there's a question about federated login. I'm not sure if you have it here or
Yeah,
you mean.
that's kind of a large question. I assume federated login, is that pertaining to Workload Factory, or is that pertaining to FSx for ONTAP? I'm not sure. And does that mean maybe federating with a provider like Okta or something like that? I don't know.
All right, we're actually over our time. If there's any last question we would like to address before we wrapping up.
Using Lens real quick, there was one little question here. Near future, I need to handle NetApp. Yeah, so if you're using Lens now and you're intending to migrate to AWS, you can use Lens with FSx for ONTAP by creating block volumes and LUNs within those iSCSI block volumes on our file system. Those can actually coexist with file volumes as well on the same file system. So I would highly encourage you to take a look at FSX for ONTAP. I assume that's what this question was asking. Workload factory in a private network. I think that there is a flavor for offline mode that Workload Factory can be used in. So if you have a product solutions architect or a cloud solutions architect that you're working with, definitely ask them about that. We just really need to look at your particular use case to make sure that that's a possibility. FSX ONTAP authentication integration with Microsoft Intra ID. I am not sure about that. I do know we do Active Directory Federation on FSX for ONTAP. So basically you would integrate the SVM of the file system into AD, which can help serve out SMB clients, etc., and also management of the SVMs. So I think it's a possibility, but I'm not familiar with Intra ID enough to be able to directly answer.
I think this is one of the cases that we would like to dive further. You're welcome to schedule a call, and we would like to discuss that in details and come prepared to that particular questions. All right. Thank you, everyone. Thank you so much for being with us today. Thank you for joining. We appreciate your time, your questions, and your engagement. We look forward to continue the conversation and see you in future session. Ty, thank you so much. And thank you, Liat and Oshrit, for running this session. So
Yep,
see you
thank you
next
very
time,
much.
all.